So we use dots to represent valence electrons. Valence electrons are the most important. They're on the outside. They're in the highest principal energy level. They are the most loosely held. They are the ones that are going to interact with other atoms. So what we do for Lewis symbols is we identify the number of valence electrons, and then we show those as dots around the element symbol. So if we look at oxygen, here's the electron configuration for oxygen. We look at this and we see that 2 is the highest principal quantum number. All the electrons in level 2, total of 6, those are the valence electrons. So the Lewis symbol is here. We take the element symbol O and we put 6 dots around it. Now we do have a way that we do that. What would a full valence shell be? How many valence electrons do the noble gases have? 8. Okay. So what works really well is we've got top and bottom and the 2 sides. That's 4 electrons. And then these are going to pair up, and those are going to pair up. And so, because this is the s orbitals and the 3p orbitals, there's 4 orbitals, they can each hold 2 electrons. So each side, top, bottom, right, and left, kind of corresponds to an orbital. And we'll put them in, for the most part, one at a time, and then pair them up if we have to. Now, does it matter if you put the pair on the top or the pair on the bottom? No, it doesn't. Here, they've got a single electron on the left and the pair on the right. I drew it the other way. That's fine. What I don't want to see is, don't want to see something like this. Let's get the right color here. That would not be correct. Okay, that's not right. Let's do another not right. Just kind of randomly in a circle. Okay, that's not right either. We're going for top, bottom, right, and left. Put them in singly first and then pair them up. That works most of the time. Any questions? So maximum of 2 per side. This is the simplest way to visual the number of valence electrons. So when we see an atom with 8 valence electrons, we say that atom has an octet. We're going to use that word a lot, octet. Atoms that have 8 valence electrons are particularly stable. The noble gases, neon through radon, 8 valence electrons. Helium's an exception. It's the baby sister of that family, and so it has a duet. But that's a full valence shell. So we have what we refer to as the Octet Rule. The Octet Rule states that atoms transfer, becoming ions, or share, making covalent bonds, electrons in a way in which they achieve an octet of valence electrons. So 8 is the magic number here. We're going to put these atoms together in a way that they end up with 8 valence electrons. That's the Octet Rule. The duet rule applies to the really, really little guys. They're too small to handle 8 electrons, right? Let's see, did I skip one? No? Okay.